Hey everybody, this is the first video on the playlist looking at GCSE iteration. There's going to be three main parts to this topic, and practically all the questions to do with iteration come in three parts for Edexcel on the GCSE. Before we start, we're going to be looking at key definitions and key ideas, and then breaking down the three main parts of this topic. So in terms of key ideas, you're going to need to know, for example, what a solution and a root is. You're going to need to know graphical representations of equations, and then sign changes. What does that all mean? And then part one of questions, usually part A, will be to do with showing there's a solution to an equation. Part B is usually rearranging to create an iterative formula, and then part C is usually using that formula that you've created. And in order to do that, you're going to need to understand things like notation, iterative process, and using the answer key on your calculator. So first of all, we need to figure out what iteration actually is. And before we do that, we need to understand what we mean by solutions. So overall, iteration is a way of solving equations which are perhaps a bit too complicated to solve just by rearranging. So first of all, let's look at what we mean by a solution to an equation. If we have a solution, what we're talking about is a value that makes an equation true. So if you have, for example, 5x minus 10 equals 20, we can rearrange that to work out what x is. And we can test, for example, x equals 6 to show that's a solution by substituting it in. So if you know that 5 times 6 is 30, 30 take away 10 gives you 20. So this is one way to show that 6 is a solution to this equation. Now, pause the video and decide for the next 4 questions, is the value given a solution to the equation given? So if x equals 2, is it a solution to this equation? So substitute and have a go. So I'm going to go through it now. So 7 take away 3 times 2. So that becomes 7 take away 6. That is not going to equal -1. It's going to equal +1. So this is not a solution. Is x equals a half a solution to the following? So 6 times a half minus 5. So 6 times a half is 3. 3 take away 5 is going to be -2. So we can see that's also not a solution. How about x equals -2 in this equation here? So if we substitute that in, you're going to get 11 times -2 squared. So that's going to be 4 plus 3. 11 times 4, 44, plus 3 is going to give you 47. So we can see that is a solution. And then we've got the final question. Pause the video and have a go. So -5 cubed is going to be -125. Take away, and then -2 squared is going to be +4. So take away 4 minus 16. Okay, and finally, question D. Substitute these values in. So you've got two potential solutions here. So put -5 in as your value for all of the x values and see if you get 0. And then try the same with -2. And then I'm going to show you the answer here. I'm not going to go through this in detail, so I think you get the big idea. So here is your answer. And what you can see is -2 works because you do get 0. But when you put -5 in, then you get -90 as your output. So -5 is not a solution, but -2 is. Okay, so let's say that two people are discussing this equation here, and one person says that -4 and 1 are solutions of the equation, and the other person says -4 and 1 are roots of the equation. So you may have come across the word roots in quadratics. So who's correct and why? Well, in this case, we can see that when you put -4 into the quadratic, you do get 0, and when you put 1 into the quadratic, you also get 0. So they are both solutions to this equation, so they both make it true. But when it comes to plotting the graph or factorizing, these solutions also work. So we can call these roots also solutions. So both people are correct in this case. So roots of an equation are the solutions when it is set equal to 0. And that's really important here. So it has to be equal to 0, then the roots become the solutions. So we're going to be using those words interchangeably in these videos as we go through it. We're also going to be using function notation. So rather than y equals, we might say, for example, f of x equals 0 or y equals f of x. Okay, so far we've looked at what we mean by roots and solutions or roots. In this case, we are going to be using both of those as long as the solution is set to, the equation is set to 0, then the solution and roots are the same. For graphical representations, we're going to look at this now. How can we represent some of these equations as graphs, and what does it mean, especially when we're referring to roots and solutions? So here we've got a graph of x squared minus 3. As we pick x values, you can see, for example, if I pick x equals -3, I get a certain y value come out, which I can read off the graph. If I set x equals -2, my y value comes out to be 1. If I set x equals -1, my y value turns out to be -2. When x equals 1, also equals -2. When x equals 2, I get this solution, y value. So these coordinate pairs are important because what we're going to do is we're going to pick out values here, and we're going to figure out the two important points here, because the roots and solutions are going to be where this graph is equal to 0, and by that we mean y is equal to 0. So when x equals -2, we can see y is 1. When x equals -1, we can see y is -2. So what that means is, in between these two values, there's going to be a y. There's going to be an x value that makes y equal to 0. We don't know what that x value is, but from the graph we can see it's closer to -2 than -1. So there's some x value that will make it 0. Now for 0, you can see the output ends up being -3. And then for 1, the output ends up being -2, and then for 2, the output is 1. So the roots of the equation here are roughly, you wouldn't perhaps get the exact answer without rearranging the actual equation, but roughly it's going to be plus or minus √3 or 1.7-ish. So these y coordinates, they change sign when you change these x values in between the roots. So you can see it goes from positive to negative. So there's a solution in between -1 and -2, which we now know is -1.7. And then they also change sign here between -2 and +1. So there's a solution between 1 and 2, which we also know is going to be +1.7. So that's how we found we know that there's a solution that exists in between these two numbers. Okay, pause the video and have a go at substituting these x values in to work out what the y values are. You can use the graph actually, because a lot of these numbers are quite nice. Okay, pause the video if you need some more time, but here are the values that you can read off the graph. They're quite nice to read. What we want to do is locate the roots. Now we can see that the roots are the 3 circled coordinates on the graph here. And what do you notice about the coordinates next to the roots? Well, we know we have a solution between 1 and 0, and we can see the sign changes from positive to negative. We also know we have another solution in between -1 and -2. And the sign changes, the y goes from negative to positive. And then in the same way, from -3 to -4, there's another solution, and the sign goes from positive to negative. So later on, we're not going to be having graphs given to us. We're just going to have to use these values and spot where the sign changes. There has to be a value in between that is a solution, in other words, where y ends up being 0. And that's essentially what we're trying to find with more complicated equations. So the thing you may notice is the y-coordinate changes sign. And what we can say is we can find roots and hence solutions by looking for the change in the y value sign. So it goes from positive to negative or negative to positive. So here's what we're going to look at is using an equation where the graph is not given. So you may not have time to draw a graph like this, or sometimes the graphs will be quite complicated. And we want to show that there's a solution between these two values. So 1 and 2. So rather than plotting the graph, we can substitute these values in. And we can say, okay, if we put 1 into this equation here, we're going to get 3 times 1 cubed, take away 2 times 1 squared, take away 6, take away 1, and that's going to be nice and easy to work out. 3 take away 2, take away 6, take away 1. So you end up with -6. And this is obviously less than 0. And we need to write this explicitly in mathematical notation. We're going to use inequality signs to do this. So in other words, -6 is less than 0. This is another way of saying -6, or our output is negative. For x equals 2, you put those into the equation here. And you're going to practice this when you get to the exercise. You're going to do similar questions. You just put 2 in, 3 times 8, 2 times 4, 6 times 2, -1. You work these out and you're going to get 3 as your output. Now that's positive. It's greater than 0. And we can see that because there is a change of sign between x1 and x2, there must be a solution between them because it's a straight line. So you know it's not a straight line, sorry, it's the curve is continuous. So there's no gaps. When you were to plot your graph, whatever it looks like, it's a continuous line. So if at one point it's negative and another point it's positive, there has to be a value in between where it's equal to 0. So just for clarity here, we've got the graph plotted on the right, and we can see that where x is 1, you get some negative value which is slightly off the grid here. It will be somewhere down there. It's going to be -6. And then for 2, it becomes +3, which is up there. So it goes from -6 to +3, and we can see, okay, well, there's some point there where it does equal 0. So the change of sign approach allows us to figure out, okay, there's a solution in between these two numbers. We may not know what it exactly is without a bit more maths, but that's going to be enough to help us out here. So especially with equations which are very difficult to solve, so think beyond quadratics. Okay, in the next video we're going to be applying this knowledge in order to answer part A of a question on iteration. I'll see you in the next video.